Till now in this lecture series we have been studying about finite automata, and under finite automata we have seen about finite automata with output and finite automata without output. And in finite automata with output we have already studied about Moore machine and Mealy machine, and we also studied how to convert one to the other. And under finite automata without output, we have already studied about DFA and NFA, and we also studied how to convert one to the other. Now the only topic that is left in this is epsilon NFA, which we will discuss in this lecture. So let's first try to understand what is this epsilon NFA. So what is this epsilon? This symbol right here is called an epsilon symbol, and this epsilon is used to represent empty symbols. So it is used to represent empty symbols or null symbols. That means it is used to represent nothing. Now that will become clear when we take an example. But before that, let us try to see how do we define this epsilon NFA. So our regular NFA was defined using 5 tuples, if you remember, which were Q, sigma, Q naught, del, and F, where Q were the set of states, sigma were the inputs, Q naught is the initial state, del is a transition function, and F is a set of final states. So even in epsilon NFA, these 5 tuples are used to define it, and Q, sigma, Q naught, and F are the same as the regular NFA, and the only thing that is different is this del. So let's see how is it different. So in our regular NFA, del was defined like this: Q cross sigma to 2 power Q. So this was the transition function del in case of our regular NFA. That means any state on getting any input, it could go to any of the 2 power Q states in that NFA. So this was for the regular NFA, but in case of epsilon NFA, what we have is that we have union epsilon over here. Now what does this mean? This means that any state on getting a particular input, it could go to any of the 2 power Q states, or it could also go to no states. And also union epsilon means that the state on seeing nothing or on seeing an empty symbol or nothing also could go to one of the states. So this will become clear when we take the example. So let me draw an epsilon NFA over here. Here A is the starting state, and we have another state B over here, and let's say we have another state C and D here, and D will be my final state. And A goes to B on getting input 0, and B goes to itself on getting input 1, and B goes to C on getting the input epsilon, and C goes to D on getting the input 1, and on getting input 0, C stays in itself. Alright, so this is a epsilon NFA. And how do you recognize it is an epsilon NFA? You see that there is an epsilon symbol used here. In a regular NFA, this symbol was not allowed. So what does this mean? We have A on getting input 0 goes to B, and B on getting input 1 stays in B itself, and on getting epsilon. Now what do I mean by getting epsilon? It means that B on seeing nothing, even on seeing nothing also, it could go to C. And then C on input 0 goes to C itself, and on 1 it goes to D. So our main focus is on this epsilon symbol. This means that B, even if it gets nothing, it can go to the next state C. So that is how the epsilon NFA works. And one thing that you need to remember is that every state on epsilon goes to itself. Let me write it down here. Every state on epsilon goes to itself. Now what do I mean by this? This means that here we have not mentioned any epsilon symbol for this A, but even if it is not mentioned, you should know that A on getting epsilon, it goes to A itself. B also on getting epsilon, it goes to B itself, and also it goes to C since it is mentioned here. And for C there is nothing mentioned for epsilon, but we should know that C on epsilon goes to C itself, and on 0 it goes to C, and on 1 it goes to D. And for D also nothing is mentioned, but you should remember that D on epsilon goes to D itself. So every state on epsilon goes to itself. This is one more point that you have to remember. Now, I hope that made the concept of epsilon NFA clear to us, and in the next lecture we will see how to convert a epsilon NFA to its equivalent NFA. So I hope this was clear to you. Thank you for watching, and see you in the next one with a conversion example.